All right. Everyone hear me okay? I noticed that some of the other ones up here had yeah, there it is, that feedback coming back. So I realized that if you stay right here, it tends to be okay. So I'm going to try and stay back here as much as I can. All right, how's that? Oh, that's much better. Perfect. All right. My name is Eric Klutz, and if you're here for SQL, this is not the SQL you've been looking for, you are in the right place. Just a little preface before we go forward. I'm kind of a huge sci-fi nerd of various genres, so as you can see, I'm starting with Star Wars here. We'll continue on and pull in a couple other things, just because showing schema with column A, column B, column C gets kind of old after a while, so kind of running something like this mixed up a little bit. All right, so I know what you must be asking yourself after reading the title. So wait a second, CQL is not SQL? And that's true, it's not. That's a common misunderstanding. What you'll see is that people will often use CQL, and a lot of the keywords will cross over, and they'll have certain expectations based on what those keywords do, based on their experience in the relational database world. Which again, that's kind of the nice thing about CQL, is that, for those of us who do have that relational background, I mean, let's be honest, that's going to be most of us. It gives you that syntax that you're familiar with, but it's important to remember that it's not a direct implementation of SQL, and that, in a low-level scenario, you could end up frustrating yourself very easily. In a worst-case scenario, you could end up building an application or, writing queries that perform very poorly if you go into it with an SQL type of expectation. So that's kind of what we want to talk about here today, and just kind of clear some things up, identify how things work, and kind of show under the hood a little bit what Cassandra is doing when you give it some of these SQL commands. Again, like I said, my name is Aaron Klutz. I work at a small startup company in Beloit, Wisconsin called AccuLinks. Got several of my coworkers here today. They're hanging out back there. AccuLinks is a cloud-based business management system designed for specialty trade contractors. So guys who are do roofing, guys who do siding, guys who do gutters, basically construction companies will use our software to manage their contacts, manage their jobs. We recently put in a ordering queue where we link up with ABC Supply, so they can go ahead and build estimates and orders, kind of on the job site if they have to. I've been using Cassandra since version 0.8. I actually used to work downtown here over at Granger, and that was where I got an introduction to Cassandra. I'm a frequent contributor to the Cassandra tag on Stack Overflow. In fact, this presentation is inspired by some of the strange things I've seen on Stack Overflow. I just felt there was a lot out there that needed to be talked about and discussed. So that was kind of the impetus for this. And last year I was named a MVP for Cassandra, Cassandra. So moving on. Again, just a quick agenda of what we're going to talk about today. Go over some SQL keywords and features real quickly that are not present in CQL. Some of the differences we'll talk about as well with the keywords that actually do crossover between CQL and SQL. I want to talk about secondary indexes a little, just because there's an expectation of how those work in the relational world, and that's not at all how they work in Cassandra. So you typically see a lot of newer developers in Cassandra will try and, I've seen somebody use 4 or 5 secondary indexes on one table before, and I wanted to cry. All right. Also want to talk a little bit about some anti-patterns that are related to CQL and SQL, and then at the end, we'll go through some questions. All right. SQL features and keywords not present in CQL. As I'm sure you've heard quite a bit, there are no joins in CQL, and that's for good reason, because when you start getting into distributed architecture, where it's got to go to multiple nodes to go ahead and pull your result set together, that can take a lot of time if they're really big. There's no there's no like keyword available in CQL. This gets asked on Stack Overflow probably once every week, at least. All right, if you need to do like queries, there are some tricks around that to implement that functionality. But the most common recommendation out there is to go ahead and use something like Solar if you have a query like that you need to fulfill. Subqueries, CQL does not allow you to do like, select from select and do a subquery like that. Lastly, I want to talk about arithmetic. If you're not incrementing a counter, or you're not adding a item to a map or a set or a list or taking one out of it, there is no arithmetic. You can't select an integer and then like +5 to it. Or you can't, divide or multiply or modulus or anything like that. Now these things you can do in SQL, but in CQL they're just not present. Well, they might be in the future, but for now they're not. All right. Here's a quick list of keywords that do cross over between CQL and SQL. And I see you taking a picture of every slide. I've actually got these out on SlideShare, so you'll totally be able to find these. Just thought I'd save you the memory on your phone there. All right. First one I want to talk about is the where clause. The big thing that you want to keep in mind when looking at the where clause and how it differs between CQL and SQL is that not all of the operators are there that you might be used to in SQL. You'll notice that it doesn't contain or, and it doesn't contain not equal. Basically, it's trying to protect you from doing something that's going to have to completely scan through a table, row by row by row by row, to build your result set. And as what has been previously mentioned, Cassandra works very well. When you give it a specific row key or a specific partition key, it can go and find that very fast. But when you start doing things like greater than, less than, in, it starts to get a little weird. So, important to note too is that also different from the relational world is that the where clause can only operate on columns that are defined in your primary key, so your primary key components. You can't just grab a random column and say, hey, give me all the values equal to whatever in this column if it's not a part of your key. And even then, it's got to be in a specific order. You can't actually skip keys. Something I wanted to show quick. Again, going with the sci-fi thing here. We'll go with real quick, I want to demo just kind of show how the where clause works and how it doesn't work. We'll go with a table design to keep track of ship crew registry from Joss Whedon's Firefly. So one thing that we'll start with here, and I should note the running joke at AccuLinks is that I have like a 90% demo failure rate. So, it's like whenever I seem to present, Wi-Fi goes out, or AirParrot doesn't like me, or I don't know, VPN goes down, whatever. So we're gonna do our best here. So I'm gonna execute a simple query here of selecting everything from that table. Love to have autocomplete in CQL shell, by the way. All right, I want to pull back all the crew members from the ship Serenity, just like that. Now, if you looked on the previous slide, actually, I can tab back to that quick. But you'll see. Sorry, that was not nearly as graceful as I pictured in my head. All right, you'll notice that defining the primary key, I've got ship name, and that's you'll notice that I don't do multiple partition keys in this example. So ship name is actually our partition key, which means that we're also going to be clustering on last name, first name, and then finally citizen ID for uniqueness. All right, made it back up. So if I want to go ahead and jump around in this query a little bit, like let's say that I want to pull back Wash and Zoe, for those of you familiar with the show. So I'll say and last name equals Washburn. Bam, that'll just bring me back Wash and Zoe. And I can do that in that order because last name is my first clustering key. All right, easy enough. So let's say that I want to go by first name. So I'll backspace over this. And we'll say Zoe, just like that. Bam, and right away, CQL doesn't like that at all. And it's because I'm skipping elements in my partition key. This is what is meant when I say that you've got to query these things in the order that they're defined in your table, in the primary key definition. And again, the reason for that is that's how Cassandra stores it on disk, that's how it orders it. And it works best when it can go ahead and pull back data in one continuous line, one continuous query, just every row right down, and fulfill those conditions. So you can't skip primary key conditions. Well, actually I lied. You can skip primary key conditions if you use allow filtering. So again, if I go back to this example, and I just go ahead and say allow filtering. Oh, what happened there? Oh, all right. Never mind. I had a different example in my head. Apologize for that. So we'll just do where last name equals Washburn and allow filtering, and that works. Now I was able to get that without specifying a partition key. And again, allow filtering allows you to do that. All right, so that's one trick there. However, I don't recommend you do that. All right, because that's one thing to show it on a table that has 9 rows in it. But when you're talking about a table that has 900 million rows in it, it's basically going to bring back every one of those rows and then try and apply your where conditions on the end of that. So allow filtering, definitely something you want to stay away from. It's definitely not something you should do in production. Kind of funny is that I was going back and forth when I was making this presentation with Luke Tillman at DataSets, and he had some alternate names that have been proposed that that haven't made their way into the code set yet for allow filtering. One I can't repeat here, but the other one is allow idiocy. So again, bottom line, if you're using allow filtering, you can usually get around having to do that by retouching your data model, maybe building another query table. That's the proper way to go about that. All right, primary keys. Primary keys, as I've kind of touched on significantly so far, they do function very differently than what you used to in relational databases. Cassandra uses primary keys to determine data distribution and on-disk sort order. Again, talk about this, the first part of the primary key is the partition key. And for those of you who have been around since the early days of using the Thrift API and using Cassandra CLI to go ahead and interact with it, partition keys are like the old school row keys. All right, that's, yeah, we'll draw there. And then clustering keys, the ones that are after partition keys, help determine the on-disk sort order within a partitioning key. All right, this is another pain point that I see violated a lot, is that someone will ask, why can't I sort my data when it's defined in my clustering key? And that's why, because it only works within a partitioning key. And I'll get into that a little in one of the next slides. Order by. Perfect segue. One of the most misunderstood aspects of CQL. And again, it's because that order by is only valid within a specific partition. All right. And the other thing about order by is that it has to match your clustering order that you have defined in your table. So really, that means when you go ahead and you query all the data in a partition, you want it ordered a certain way, you don't really need order by because you've already done that when you've defined your table. So you might be asking, well, then really what does order by do? Well, it lets you flip the sort direction, I believe, on only the first clustering column. So if you have like a time series model that's ordering, it's partitioning off, and then within that partition it's ordering by like timestamp or date received or whatever. And you've got that on descending because you want to pull back the most recent values by default. Well, if you want, and you're looking at it, you can flip that to be ascending instead. You can do that with order by. All right, quick example here. I tried to bold the important parts based on the slides we were just talking about. But let's say we're putting together a website for people will post like movie quotes on it. And you want to keep track of posts by user year. So essentially what this does is you see the primary key definition actually has a composite partition key defined. So I'm partitioning by both user ID and by year. And then in addition to that, I'm clustering on post time and then by tag. And you can see the clustering order underneath there that I've got post time going in a descending order because when, for whatever reason, my default requirements are that I want to be able to see the most recent of these posts up on top. So let's go ahead and try some queries here. So if I say select star from posts by user, oh, did I? Oh, I forgot an S. There we go, post by user year. And I'm going to say where user ID equals 2. Oh, and that's not going to work because I defined that field as text. That wasn't very right. All right, this failed for the reason I wanted to demonstrate. Because I've only given it part of my partitioning key. Again, you have to give it the complete partitioning key in order to get queries like this to work. So what I'm going to do instead is say and year equals 2015. All right, this brings back all of the posts for user 2 for the year 2015. And you can see they are in order by post time order. 13, 28, 27, 26, 24, 23, just like that. So how about if I backspace over my where clause completely, and I say order by, post time. Just like that. Well, again, that's going to say that this is invalid because it's telling me straight up that it's not going to give me any answers back unless I'm first giving it a partitioning key. I'm first giving it a specific place to go to. So, which is why my last query worked, because I did give it the full partitioning key. And I'm done with that one. The last one here, let's switch back. So we give it the full partitioning key, and let's say order by tag. Well, that doesn't work because I'm skipping columns in my clustering key again. All right. Primarily, I'm working on post time. Tag is like a secondary one, and I'm trying to go right to tag, and it's not going to let me do that. So again, you have to make sure you're querying these things in the order that you have them defined. All right, in. In is kind of a tricky one. You'll notice that in the DataStax documentation, they talk a lot about how restrictions for using secondary indexes typically also apply to using in. It's designed so that it can only operate on the last partitioning key or the last clustering key, which also means that you have to restrict the first one or all the ones preceding that by an equals condition. Or if it's the only one in there, you can just do an in on that. But and actually, last week I learned on Stack Overflow actually that you can do both. You can restrict on both partitioning key and clustering key at the same time if you really feel like torturing your cluster. So I don't recommend that at all. Like I said, it doesn't perform well, especially if you have large clusters where it's got to go to multiple nodes to bring your result set back. All right, so to test in, I've created a table based on the sci-fi classic 1982 Blade Runner, also based on a novel by Philip K. Dick. Let's say we want to create a table to keep track of our Blade Runners. So I'll go ahead and do a select star from Blade Runners, just like that. It'll go ahead and it'll bring back my table of Blade Runners. Now let's say that I only want to bring back Deckard and Holden. So I'll say where ID in. All right. Without looking up there, who can tell me? Who's seen this movie tons of times too? Can tell me Deckard's ID number? Oh no! Oh, I'm just. It's B26354. And Holden's isn't mentioned in the movie, so I had to actually conjure one up for him. So we'll say Holden is 25881.
Is that the B?
Oh, did I forget that? Oh, I forgot the B in Deckard's. Look at that. There we go. All right, so if I go ahead and I run this inquiry, bam, it brings back just those 2 rows. And ironically, this is aside from the performance, this is the same way that it functions when I run it in the relational world. So here I have an instance running on MariaDB. For those of you that don't know, I believe it was the fork of MySQL after Oracle purchased it. So if I go ahead and I run a similar query here, actually, you know what would be really easy? Because if I just went and now my mouse isn't working. Outstanding. There's that 90% failure rate right there. All right. It's got to be this glossy surface on the podium here. That's right. That's not going to work. All right. So let's tab back to here, and I'll paste that query in. Same thing, I want blade orders back where I've got Deckard's ID and Holden's ID. And I go ahead and run that against my SQL, and it brings back the rows I wanted just fine. Now, what if I make a mistake here when I'm running my query? Let's say I accidentally put in Deckard's ID twice. B26354. So you notice it's in my inquiry twice in that list. I'll go ahead and select it. Well, my SQL knows how to go ahead and pull out the dupes for you. I'm not exactly sure how that works under the covers, but it knows to only give you one row back. Of course, now that I've shown you that, does anyone have any intuition as to how Cassandra is going to behave? 26354. Oh, guess what? I pulled back Deckard twice. So essentially what this is doing, this is what's known as a multi-key query and has been identified as an anti-pattern. Right? So I'm going in, I'm giving Cassandra a list of keys, and I'm saying, give me this key, give me this key. And when it goes ahead and it runs the queries through, it doesn't know that it's the same key. So when it finds it the first time, well, it doesn't know that it shouldn't go ahead and give you the next one too. So it does that. And you know what, I'm not going to do it, but if you were to keep on adding those IDs, you would keep increasing your row size. So that's important to remember how it works and how it doesn't work. Oh, where is, hey, there we go. All right, yep, did that. Okay, distinct. Doing a select distinct. In the relational world, this can hurt a lot. Actually, when I first got to Acculinks, I was given a query to clean up. That was on one of our store procedures, and we had a previous developer who had written, and I'm not kidding you, it was a triple nested distinct. All right, so it was doing a select. The select was distincted. That was union to another select that was also distincted. It was inside a subquery, which was also distinct. It was horrible, and of course the query performed horribly. So the first thing I did was go and took all the distincts and made it work without having to use distinct, and that brought performance down dramatically. Cassandra, on the other hand, works significantly different with distinct. It really only returns the row keys or your partition keys. So if you want a quick list of all the row keys that you've got, and assuming, the performance is going to be relative to the size of your cluster, relative to the amount of rows in your table that you're trying to pull this back from. But when compared to its relational counterpart, this is actually a fairly lightweight operation because you're really just pulling the key back. Count. This one's a little trickier. Again, it functions very similarly to its relational counterpart. Goes ahead and returns the number of rows requested, or based on the table query, depending on the where clause. Does not aggregate, but again, you don't have anything to join it to, anything to group by, so you don't need to worry about that too much. It can be inadvertently restricted by limit, and I think one of the presentations earlier this morning kind of showed that, where if you're trying to do a count on a table that has more than 10,000 rows, it'll actually kind of chop it at 10,000 unless you tell it to go beyond that. This is a very resource-intensive command actually, because in order to get an actual count, it has to go through, it has to iterate through every row that you've got out there. Partition rows and CQL rows, it's got to go through each one. It's got to bring them back, count them up, and this one can time out if you try and use it on a table that's too big. For a good explanation on this, and I actually have this linked in my additional readings on the end, and I'll have that up as well. Apple's Richard Lowe actually wrote a really good blog post about 2 years ago on how exactly CQL count works and what it's doing under the hood, and it, I found it really informative and actually used quite a bit of it for that slide there. And for those of you who are at the Cassandra Summit in San Francisco this year, Richard Lowe is the one who presented on Apple's use of Cassandra and how they have like a 75,000 nodes, and I'm trying to remember how much data they have. It's like in the teens of petabytes. It's pretty crazy what they use. All right, talk a little bit about limit. Again, it can limit your query where limit n where n is a positive integer. But unlike the relational databases that do implement it, it doesn't allow you to specify a start point. So you can't really use it to page through your results set. So quick demonstration on that is, let's say that I did a select star, and I wanted to do a limit 2. Oops, I need a space there. It'll just bring back the first 2 rows that it gets back. And also important to note too, is that if you ever wonder what order they're coming back in, your partition keys are coming back in by default, you can use the token function. That'll actually get you the hash that is used to figure out where in the cluster it's going to put it. I'll just say name. All right. And as you can see, they just brought back the first 2. And, well, it's not as apparent when I use limit, but let me back up here. As you can see, the rows that come back are actually in order by their hash partition keys. So that's important to understand when you're trying to go through and try to pull some of these rows back. Let's see here. All right, Cassandra upserts. Cassandra does have keywords for insert and update, as I'm sure most of you know. They're colloquially called upserts because, well, under the hood, Cassandra treats insert and update the exact same way. You have to give it the complete primary key in order to perform a successful insert or update. But the reason that they operate the same is that, again, it's been mentioned, but Cassandra doesn't do a read before it does a write. Yeah, so, let's see, they both require. There are times when you would want to use one over the other. Oh yeah, why the different syntax? Gives you some flexibility. Update is really the only one that you can increment counters with. So if you're using counters, and I believe you actually need I've never actually used them in prod, but if you do, I believe you actually need a table that only has counter columns in it. It doesn't work well by just throwing a counter onto an existing table that has non-counter data in it. So update is the only one that lets you do that. And the reason for that is that you can't actually insert an initial value into a counter. When you create them, they're at 0, you either increment them or you decrement them. That's how they work. One thing I noticed though about, because you may ask, well then why would I ever want to use an insert? Inserts can actually save you some dev time when you're in the application layer. Let's say that you've got a table where you're not going to create a new column, but you've got an existing column that you want to make part of your primary key. Let's say you're in the development phase, stage of your project, and you want to move one of your columns to become a part of the primary key. Well, in Cassandra, that's a nuke and pave type of operation. You have to blow away the table, recreate the schema, go ahead and copy your data back in. But the nice thing about that is if you use inserts at your application level, your data is already there. It's already in your values list. If you use update, you have to go ahead and move those columns from the set list, or the set clause actually, down into the where clause instead, because that's where the key values go when you go ahead and you do an update. So insert in the application level can actually save you a little bit if that's a situation you find yourself in. Again, got an upsert example going into our Blade Runners table. If Captain Harry Bryant didn't exist in that table, that full update command would actually insert him in there. And likewise, the bottom one will just go ahead and alter the data, or whatever his quote is. Likewise, if you want to insert Gaff into the Blade Runners table, you can go ahead and use a full insert, or if you just want to update Gaff's quote, you can go ahead and just do it with the values that are going to change, well, the key and then the value that's going to change in the insert clause. Another tricky part too, you'll notice that if you're working a lot from the SQL shell command line, which I do because I'm a command line type guy, if you have a apostrophe, make sure you go ahead and double them up to escape those out. Otherwise, it'll think that you're closing off your column value. All right, got through all the SQL, CQL keywords. Moving on to secondary indexes. Just want to talk about these for a little bit. Again, Cassandra provides them to allow for queries on non-partition key columns. As of 2.1, you can even create secondary indexes on collections and on user-defined types. But it's important to remember that when you do these things, that they're designed for convenience, not for performance. They don't perform well on high cardinality columns. Again, this is something that I see being abused on Stack Overflow a lot. Someone will create a table, and they'll be in a very relational mindset, and you'll see they have like 4 secondary indexes, and some of them are on very unique fields. And when you create a secondary index, it actually creates a table or column family behind the scenes where it stores your index key and those values. And if it's high cardinality, what's going to happen is you're basically going to have a row in that new secondary index table for every row that's already in your main table. So in that case, you might as well go ahead and create an additional query table. Extremely low cardinality is also not a good idea. Columns that are like gender, you really don't have only 2 options. Let's see, Booleans, trues and falses. Those are things that, again, you wouldn't want to go ahead and create a secondary index on. Because think about it, if you have, again, 900 million rows out there in that table, and let's say you have an even distribution of users, you'll go ahead and pull back half of that table based on that index, and that will not perform well. Maybe where that would sort of work would be if you were looking at gender based on developers. Out of 100 million developers, you probably have 2 that are female. But even then, you think about it, it's got to ignore all the other rows that are in that table, so really just not a good idea. It's important to note, too, that you have low performance on a frequently updated column, because what's going to happen is that you have a column that's constantly being written to, constantly being deleted. It's creating, who knows, starts with a T. They made a movie about it. Well, not really. Tombstones, yes. All right? So, tombstones are things that, again, Cassandra kind of has to work around if you have too many of them out there. So, in my opinion, I got to actually go in at AccuLinks and bring Cassandra to us and kind of use it to help scale out part of our ordering system. And I'm proud to say that I built that entire thing secondary index free. So, yeah, in my opinion, I would just avoid them altogether. Anti-pattern. I talked a little bit about this. Like I mentioned, multi-key querying with the in is a definite anti-pattern. Secondary indexes, we'll talk about that. Deletes or using Cassandra as a queue or something for lots of transient data will also create a lot of tombstones. Inserting null values, every time you insert a null value, creates a tombstone. A big culprit of that is when you write like application side code and you're creating a prepared statement and you've got values in most of them, but some of them you don't, so your application sends those over as null. Well, guess what's happening? All right. While CQL is designed to make use of our previous experience using SQL, it's important to remember, again, and I've said this a lot, that the two do not behave the same. And even if you consider yourself an expert in SQL, it's very important that you go through and read the CQL documentation, especially that one on the select, quite thoroughly before you make any assumptions about how you think it's going to work. And I remember when I first started with CQL, I did the exact same thing. We were building an application at Granger, and I went through and I'm like, I want to be able to query on all these other columns. Query on all these other columns. So I created like 3 secondary indexes, and I used allow filtering. I'm like, wow, this is awesome. Yeah, that didn't make it out of that thing. Yeah. All right. Well, at least the allow filtering part. For some additional reading, there's an article that Patrick McFadden, I don't know if he's here, he had a session going on at the same time next door. Anyways, Patrick wrote about getting started with time series data modeling. It talks a lot about how to make order buys work properly. It talks a lot about how to partition your data properly. Of course, there's also the select dataset SQL 3.1 documentation, which I admit that's a little dry, but there are things in there that are important to understand if you're going to be building these types of applications, building these types of queries. You really have to look through that. Again, I mentioned Richard Lowe's article, Counting Keys in Cassandra. I think he published that on Planet Cassandra in like 2013, but it was right around, I'm trying to remember, it was right around, might have been right before Cassandra 2.0. But again, very good in-depth discussion on what happens when you're doing an account, as well as some other things behind the scenes. And for those who haven't picked it up yet, Cassandra High Availability by Robbie Strickland. Funny story about that. My wife and I were actually in the car at like 4 in the morning
going to the Milwaukee airport on our way to the Cassandra Summit, and it was raining out. She looks at the Weather Channel app, and Robbie's the head of engineering over at the Weather Channel, and she's like, "It says it's not raining, but it's definitely raining." And I'm like, "Well, when we get there, you can ask Robbie Strickland about that." And sure enough, she didn't end up sitting right next to him, and I ended up introducing him. That was kind of fun. So, but his book actually just came out at the beginning of December. It's very good. Yeah, and it's definitely not a beginner book, so it's definitely for this type of an audience. You know, if you use Cassandra for a bit, you want to know how to tweak it operationally, you want to know how to build queries out of the form. This is very good, and I think when I got it new, it was like $22. I'm sure it's gone down a little bit since then, but that's very good. All right. Are there any questions?